Alright, so here again is the example we were working on in class, and this once again had to do with the supply and demand and price of cherries. So we completed part 1 together, but just to remind you that we were looking for the price-supply equation, and we let the independent variable x represent the supply in thousands of pounds, and the dependent variable y represent the price in dollars. We wrote two ordered pairs based on these variables. 16 and 1.88 was for the first price with the supply that was given, and the second ordered pair was 10, 1.46, and that was for the second price of $1.46 and the supply that was given. Notice again we are writing this in thousands of pounds. So we wrote this price-supply equation by finding the slope, plugging in y2 minus y1 over x2 minus x1 to get the slope is 0.7, or excuse me, 0.07, and then we plug that into our point slope formula and solve for y to get the equation y equals 0.07x plus 0.76. Now we're going to follow the same steps to find the price-demand equation. So x here represents the demand, y represents the price. We set up two ordered pairs. The first price was $1.88 and the demand was 10.6 in thousands. The second case, the price was $1.46 and the demand was 12.7 in thousands. Find the slope, so once again, y2 minus y1 over x2 minus x1. Your slope is negative 0.2. Plugging that into your point slope formula. Using one of the points, I just happened to, again, use the first point. You could have used the second point here, and that would give you the same equation, y equals negative 0.2x plus 4. Step 3, we're finding the supply and demand at a price of $2.09 per pound. So we're using the two equations that we have already found in parts 1 and 2 and plugging in 2.09 for the price, which is the y value. And then you're going to go ahead and solve for x. And for supply, you get 19,000 pounds. For the demand, you're plugging in 2.09 for the y in the demand equation. When you solve for x, you get 9.55, which is 9,550 pounds. Alright, so the second part is asking you to compare the supply and demand. So here the supply of cherries is greater than the demand for the cherries. As a result, do you think the price of the cherries will increase or decrease? Well, if the supply is greater than the demand, that means there are lots of cherries available but nobody really wants them, the price is going to go down to try and get rid of the cherries. So the price here will decrease. Question 4, you're finding the supply and demand at a price of $1.32 per pound. So it's the same steps as we did in step 3, it's just a different price. So for the supply, you're plugging in 1.32 for y. When you solve for x, you get 8, which is 8,000 pounds. For demand, you plug in 1.32 for y, solve for x, which is 13.4, so it's 13,400 pounds. So here, comparing the supply and demand, supply of the cherries is less than the demand for the cherries. And again, since there are not very many cherries, but a lot of people want them, the price is going to increase because people will be willing to pay more for them. Now, eventually this back and forth will try to reach an equilibrium. So we want to try and find the equilibrium price, equilibrium supply, and equilibrium demand. And we're going to do this by solving the system of equations that we've created. And we're going to do this graphically, although of course you can do it algebraically. So in your graphing calculator, I've already entered in the two equations here, so you should do the same. Remember to use this button here for the variable x. I'm going to go ahead and click Graph. Now I might not see where these two lines intersect. It seems to be a little bit off the screen, so I can go to the window and adjust it. I need to move my screen a little bit to the right, which means I have to increase my x max. So let me try making it 20 and see if that does it. Go back to Graph. And as long as I see where they cross, I'm fine. And I do see that right here. Alright, so the next thing I'm going to do is find the intersection point. So we're going to second, and then the trace button. Notice right above it says calc in blue. And we want to find the intersect. You can arrow down or just press number 5 and then enter. And you'll see your cursor blinking on the screen. So you move your arrow either left or right and get it to where you think the intersection point is, which I think is about here. Notice it's asking me for the first curve. I'm going to say yes, that's where it is on the first curve. Press enter. Now it's asking me for the second curve. Doesn't look like my cursor moved at all, but it is in fact on the other line. But it should still be where I think the intersection is, so I'll say yes, that's where it is. Press enter, and then it'll ask me to guess. Well, not me to guess, it'll ask the calculator to guess, and I'll say yes, please guess. And it tells me the intersection point is at when x is 12 and y is 1.6. Slide this over. So it's my solution here, the ordered pair 12, 1.6. Now we can go back and interpret that into our application. So that means that our x value was 12, and that was the supply and the demand in thousands of pounds. So the supply and demand is equal at 12,000 pounds, and the price is $1.60. So if the supply and demand are equal, which means we have a 12,000 pounds supply, and that's how much people are looking for, the price will be set at $1.60, and this will be in equilibrium. It will stay that way as long as the supply and demand remain the same.